Ladies and gentlemen, welcome to SQL Server Performance Monitoring and Tuning video brought to you by SQLworkshops.com. In this video, we will take a look at SQL Server configuration parameter optimized for ad hoc workloads. Configuration parameter optimized for ad hoc workloads can reduce memory usage of planned cache when there are lots of single-use ad hoc or dynamic SQL statements. On the other hand, if most of the ad hoc or dynamic SQL statements execute more than once, this can lead to unnecessary CPU usage. Let's look at an example. To follow this example along with me, you need the SQL test tool. To get the SQL test tool, you can go to the website sqltest.org and click on download. There you will find the link to install SQL test. Once you have the SQL test tool installed, you can click on File, Open Online Examples. There you will find the example SQL test _ optimized for ad hoc workloads. Let's click OK to open this example. In this example, we are creating two tables. Table 72 has 4 columns. C1 integer, primary key, C2 and C3 are also integers, C4 character 2000. We create an index on column C2 and C3, and then we insert 2000 rows into this table. Table 73 has 3 columns, C1 integer primary key, C2 integer, and C3 character 2000. We insert 200,000 rows into this table. To create these tables, you can click on Workload 4 and click on Start Current. Tables have been created. Now we can click on Settings and Comments, and we can copy these statements to one of our Management Studio windows. Let's see what is in table tab 72. There you see the column value C1 increases. It goes from 1 until 2000. Column value C2 repeats 1 4 times, 2 4 times, and so on. For C3, value 1 and 2 repeats. Let's execute this statement. Select from tab 72 where C2 equal to 1 and C3 equal to 1. We get 2 rows. What we want to do is execute 1000 such unique statements. That is statements with unique set of predicates. C2 equal to 1, C3 equal to 1, C2 equal to 1, C3 equal to 2, until C2 equal to 500, C3 equal to 1, C2 equal to 500, C3 equal to 2. The way we are going to execute these statements is using SQL test tool. Let's go to SQL test tool. Let's go to workload 1. We are going to execute this statement 1000 times, number of iterations 1000. We have placeholder instead of values for at C2 and at C3. And when you go to settings and workload settings, there you will find we have substitute values checked. So SQL test tool will call a store procedure, and it will use the result set to substitute values for at C2 and at C3. Let's look at that store procedure. Let's go to workload 3. Here is the store procedure. Let's copy this into a Management Studio window. Here is the store procedure that the SQL test tool will call. SQL test _ substitute values. When the command text is like this, which is in our case, it will execute this statement, and our workload will get these values for substitution. C2 1, C3 1, C2 1, C3 2, until C2 500, C3 2. Let's go to SQL test tool. In workload 3, we have 2 store procedures. One is for value substitution, other one is for parameterization. We will look at this a bit later. To create these stored procedures, we can click on workload 3 and start current. If you want to keep these stored procedures in a different instance of SQL Server for supplying substitution values or parameterized values, then you can create them on a different instance, and then you have to go to settings, general settings, and you have to give the connection string where these stored procedures are located. We will use the same instance. Let's create these stored procedures. Let's go to workload 1 and let's start this workload for 1000 iterations. Before doing that, let's go to Tools, SQL Server Profiler. Let's start the profiler with a default template. Now let's go to SQL Test Tool and start this workload. Now let's go to the profiler and see how these statements got executed. C2 equal to 500, C3 equal to 1, C2 equal to 500, C3 equal to 2. So we have 1000 unique statements executed, that is with unique set of predicates. Now let's go to the Management Studio and let's do free proc cache. Let's get rid of all the plans in the cache. Let's go to workload 1 and we will start this workload. No plans are in the cache. SQL Server is optimizing for the first time. Look at the execution time. It's around 4.5 milliseconds. If you go to Tools, you can click on average DB time in milliseconds if you want this time in milliseconds. If you execute this statement again, SQL Server will find those plans in the cache and it will execute, and the execution will be faster. Let's do this. There you see now it takes only 2.6 milliseconds instead of 4.5 milliseconds. Let's look at the query stats. There you see we have 1000 rows. SQL Server has 1000 statements in the cache and 1000 plans. The first one is C2 equal to 420, C3 equal to 1, C2 equal to 11, C3 equal to 1. Let's look at the execution plan. When you go here, look at the index seek. There you see in seek predicate 420 and 1. Let's close this. Let's open the next execution plan. There you will see 11 and 1. So SQL Server has 1000 unique statements and 1000 plans. Let's look at the size of these plans by querying cached plans. You see each plan is about 32 kilobyte. Let's do a sum of size. There you see for 1000 plans, SQL Server takes about 32 megabyte. So SQL Server caches the plan on fast execution, and if you have these ad hoc or dynamic SQL statement executed once and never again, these plans stay in the cache, occupy space, and is not beneficial. This is where optimize for ad hoc workloads configuration parameter come into play. Let's execute this statement to enable optimize for ad hoc workloads configuration. Now let's go back and clear the proc cache. Now on the first execution, it will take about 4.6 milliseconds. On the second execution, it will take again 4.6 milliseconds because SQL will not cache the plan on first execution. Let's look at it. Let's do a start current. You see 4.5 milliseconds on an average. If I go to query stats and look at the plan, you see the plan is null. We still have 1000 unique statements, but the plan is null. If you go to cached plans, there you will see again the plan is null. SQL has something called compiled plan stub, which takes 352 bytes. This is to identify when the same statement comes again, SQL Server to cache the plan. So if you look at the size of bytes used for this 1000 compiled plan stub, it's only 343 kilobyte, not 32 megabyte. If we go to the SQL test tool and execute this workload the second time, now SQL is caching the plan, and that's also a reason why the execution time did not decrease to 2.6. It is caching this time. Previously, it prepared a plan, it didn't cache. This time, it is caching the plan. So if you go back here and you look at the query stats, there you will see SQL cached the plans. And if you go to the cached plans, you see each plan now taking 32 kilobyte. And if we look at the size of all plans, there you see for 1000 plans, it takes about 32 megabyte. So if you have such ad hoc or dynamic SQL statement executing more than once, then SQL will optimize these statements 2 times before caching them. So you have to be careful when to enable this optimize for ad hoc workloads configuration parameter. You can use these 2 queries to decide when to enable them. Right now, let's go and disable this configuration, optimize for ad hoc workloads. Now we will clear the proc cache. We will go back here and we will execute this workload for the first time after clearing the plan cache. If you go back and execute this statement which says use count equal to 1 and the statement which says use counts greater than 1, you will see we have 1000 ad hoc statements which occupy 32 megabyte with use counts 1. With use counts greater than 1, we have no statements. This means we have single use statements, and enabling this configuration parameter is very helpful. If we go back and execute this workload again, now you see we have no statements that have use counts 1, the ad hoc statements, but we have 1000 statements which have use count greater than 1. In this case, it is not beneficial to implement this configuration parameter optimize for ad hoc workloads. I want to show you one more example how SQL Server treats ad hoc statements and dynamic SQL statements. Let's go and copy this text. Let's free the proc cache. Let's copy this dynamic statement in the workload 1. First time when I execute, SQL Server will prepare the plan for the first time and the execution will be around 4.6 or 4.5 milliseconds. If we undo this and execute the original statement, which is the ad hoc statement, SQL will start reusing the plan. What I want to show you is the plan caching mechanism is the same for ad hoc statements and dynamic SQL statements. Let's do start current. SQL Server will have a cache hit, that is, it will start reusing the plans and it will not take 4.6 milliseconds. Start current, you see it is taking only 2.5 milliseconds. These kind of statements pollute the plan cache with different predicates, even though the statements are the same. The way to investigate this is you can execute the following query, which selects from query stats. We are going to look at query hash and query plan hash. In SQL Server, when the statements and queries differ only by literals, they will have the same query hash and query plan hash. So when you execute this, you will see all of our 1000 statements have same query hash and same query plan hash. So they differ only by the literals. When the query hash and query plan hash is same for all of our queries, then we can parameterize this statement. So SQL Server can have one plan and start reusing that plan. If for the same query hash you have more than one query plan hash, then you should not parameterize. This can lead to non-optimal execution plans. Let's parameterize, since in our case query hash and query plan hash is the same for all 1000 statements. For this, we are going to workload 1 and going to settings, workload settings, and we are checking parameterize query instead of substitute values. Let's press OK. When you do that, the SQL test tool will call a stored procedure named SQL test underscore parameter values and will use the result set to supply parameter after parameterizing the query. We created this stored procedure when we executed workload 3. Now let's start this. Let's go to Management Studio. Let's free the proc cache. So we have no plans in the cache. Go to workload 1. Let's start current. Since the query will be parameterized, the first execution will take 4.7 or 4.6 milliseconds. The rest of the 999 iterations will take 2.5 or 2.6 milliseconds. So the average will drop. It will not stay at 4.5. It will drop to around 2.6. Let's do a start current. You see, it is 2.5. It did not stay at 4.5 or 4.6 because SQL Server cached the plan, a single plan, and it started reusing the plan. Let's go to Profiler and see how these queries got executed. So when you go here, you see SP execute SQL. It supplies the statement, and every time it supplies different set of parameters. One more thing you can do is you can go to settings, workload settings, and you can click on prepare. When you prepare, the SQL test tool will prepare the statement, and when you go to Profiler, there you will see it is simply doing prepare exec. In this case, it does prepare exec every time because we are connecting to SQL Server before every iteration. So the previous preparation is lost. If you uncheck this button and if you press OK and then you start current, there you will see SQL test tool prepared the statement once and it is simply executing. Let's look at a final example. Let's go to workload 2. In workload 2, we are executing a query based on tab 73. Here we are joining this tab 73 8 times. The reason I want to show this to you is the compilation time will be very high. We are executing this 5 times. Again, we have substitute values. There you see. And we are substituting value for at C2. If you go to our stored procedure, there you will find a comment, I need a value for C2. When the command text contains this comment, then you will get these parameters for substitution. So here we have the comment, I need a value for C2. So let's go to Management Studio, clear the proc cache. Let's execute this statement, this workload. each execution takes around 1.3 seconds. You see here, if I execute again, it's quite fast. Let's go and look at the execution plan. Query stats, query plan, click on this and right click on the select statement and click on properties. There you see the compile CPU time and the compile time around 1.1 second. So every time SQL Server compiles the statement, it takes 1 second. That's why the initial execution was 1.3 seconds. Now it is only 0.268 seconds. If we have option optimize for ad hoc workloads enabled, and then if we have dpcc free proc cache executed, and if you execute workload 2, on the first execution it will take 1.3 seconds. On the second execution it will take again 1.3 seconds because SQL will not cache these plans on the first execution. On the third execution it will take only 270 milliseconds because SQL Server has cached the plans. Let's make a summary. SQL Server configuration parameter optimized for ad hoc workloads can be very useful when you execute lots of single-use ad hoc statements or dynamic SQL statements. If the majority of ad hoc statements or dynamic SQL statements execute more than once, then optimize for ad hoc workloads configuration parameter can increase the CPU usage, and hence it is not recommended in such scenarios. When the plan is stable, that is, when the query hash and query plan hash is the same for all executions, it is recommended that you parameterize these statements to reduce plan cache pollution. In a future video, I will talk about query parameterization, that is, auto parameterization, safe parameterization, unsafe parameterization, explicit parameterization, and forced parameterization. Thanks for watching the video. Send me your comments and suggestions by email. Bye.